Hello everyone, welcome back to Functional Studies 101. Today we have an interesting exercise to look at, which is the Adamawa Regional Competition of Mathematics. So before we get to the solution, if you are new to this YouTube channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that whenever new uploads are made available, you will not be left out. You'll be the first to be notified by YouTube. To get to me, you can inbox me or email me at temgun48@gmail.com, or you can send me a WhatsApp message using the number on the screen. So this is exercise 1 on the paper. So without wasting much of your time, let's get into this. So the question reads that let U, V, W be real numbers in a geometric progression, that's a GP, such that U is greater than V, which is in turn greater than W. Suppose that U raised to the power 40 is equals to V to the power N, which is also equals to W raised to the power 60. Suppose that these three terms are equal. What is the value of N? That is what the question is asking. So we know that the three terms U, V, and W are in a geometric progression, so there exists a common ratio between them. So let R be that common ratio. So my R is a common ratio. So it means that since my first term is U, to move to the next term in the progression, I'll have to multiply this first term by R, that's the previous term by R. So my next term will be U times R. So to move to the next term, I have to multiply this term by R again to get the next term. Since the common ratio is R, so it means that I'll have U times R, that's UR times R is UR squared. Having these three terms, this is my V, this is my this is my U, this is my V, and this is my W in that order. We use the fact that we are asked to suppose that these three terms are equal. So U raised to the power 40 is equals to V to the power N. So U raised to the power 40 is equals to what? V to the power N. And my V is what? U raised to the power R. So in that case, we'll have U raised to the power U, that's U times R. Everything raised to the power N, because V is raised to the power N and V is U to the power R. Simplifying this using laws of indices will give us U to the power N times R to the power N. This is my equation 1. Again, we know that U raised to the power 40 is also equals to what? W to the power 60, and W is equals to UR squared. So it means that we will have U to the power 40 to be equals to what? U times R squared, all raised to the power 60, since W is raised to the power 60. Simplifying this gives us U to the power 60 times R to the power 120, because you know you have to multiply the numbers, right? Distribute the powers and multiply here. 2 times 60 is 120. This is my equation 2. So to simplify this, we have to solve these two equations, manipulating them such that we will have to look for a way to get N, and follow up in this tutorial as we disclose our own approach. So taking natural logarithms on both sides of equation 1, we'll have the natural log of U to the power 40 to be equal to the natural log of this. Okay, now you can simplify using laws of logarithm here. So this will just be the 40 can just go behind the power rule. So this one will become 40 natural log of U to be equals to what? Here is a product of two functions. That's U is the power N times R to the power N. So since it's a product, according to laws of natural logarithm, this will be the natural log of U to the power N plus the natural log of what? R to the power N. The natural log of U to the power N is just N natural log of U, since the power will go behind, plus the N natural log of R, since the power also go behind. That's applying the product to some relation. So this is my equation 3. I'll call this equation 3. Now, having this equation 3, we'll take natural logarithms on both sides of equation 2 as well. So taking natural logarithm on both sides of equation 2 will give us the natural log of u to the power 40, that's equation 2. The left hand side will be equals to what? The natural log of u to the power 60 times r to the power 120. From here we have to apply again the laws of logarithm. The 40 goes down, so it will be 40 natural log of u equals to what? Since a product here again, and we have to apply the power rule, so it will be 60 natural log of u plus 120 natural log of r. We notice that 40 natural log of u and 60 natural log of u are common terms, so we can bring them together. So that will give me 120 natural log of r to be equals to 40 minus 60. That will be negative 120, negative 20 natural log of u. So here we can divide both sides by 120. That will give me negative 1. Okay, where you divide here, 20 divided by 120 is 1 on 6. So it will be negative 1 on 6 natural log of u. So this is my equation 4. We have to now do what? We replace this guy in equation 3. So my equation 3 was the 40 natural log of u equals to n natural log of u plus n natural log of r. So in that case, I know that that was my equation 3, and my equation 4 was just natural log of r to be equals to minus 1 on 6 natural log of u, which is equals to 4. Then now we have to replace natural log of r in this equation. So you see that we will transform this equation now to be only a function of natural log of u. That will give us 40 natural log of u to be equals to n natural log of u plus, so I will just replace natural log of r by minus 1 on 6 natural log of u. So this one, the n will just be negative n on 6 now. So it will be negative n on 6 natural log of u, replacing natural log of r in equation 3. So we notice here that natural log of u is common throughout. So for this n to exist, clearly natural log of u should not be equal to 0, and that can only happen when u is not equal to 1. If u is equal to 1, everything will be 0. So in that case, we suppose that u is different to 1 so that n will exist. Okay, so from here we can have that cancelling out this. If we assume this, we can cancel out the natural log of u, be left with 40 equals to n, okay, minus 1 on n. That's n on 6, sorry. So from here we can multiply, this is just a linear equation, we can multiply both sides by 6. That will give me 240 equals to what? 6n minus n. Finally, 6n minus n is 5n, so we have 240 to be equals to 5n, and dividing both sides by 5 gives us n to be equals to 48. So this is the end of the video. Thank you all for watching. I hope you enjoyed it. See you guys in the next tutorial. But please don't forget to subscribe, share the video to the widest audience, share to your students, your mates, your friends. Let the video go viral. That will make me very happy. Hope you enjoy it, and see you in the next tutorial. This is Temgun48 signing out. Bye bye.